So the first example we're going to do is binary. If we choose 2 as a base, that gives us binary expansions of integers. In binary notation, each digit is either a 0 or a 1, because those are all the non-negative integers that are less than 2. So everything is a 0 or a 1. In other words, binary expansion of an integer is just a bit string. So let's see how we can write this binary number as a decimal. So we have this binary, and we're going to write it as a decimal. Well, we do that by writing out the binary expansion. So here's how that works. We have 1, 0, 1, 0, 1, 1, 1, 1, 1, base 2. And I want to expand that out. So this is going to be equal to 1 times 2. So what power? Well, here is the 0 power, the first power, second, third, fourth, fifth, sixth, seventh, eighth. So this is 1 times 2 to the 8th power plus 0 times 2 to the 7th power. That comes from this 0 plus 1 times 2 to the 6th power plus 0 times 2 to the 5th power plus 1 times 2 to the 4th plus 1 times 2 cubed plus 1 times 2 squared plus 1 times 2 to the 1st plus 1 times 2 to the 0th. And then we just have to do all this arithmetic. So, you do this out by hand, get out your calculator or whatever. But when you do all the arithmetic, when you take all these powers of 2 and then do the multiplication, this is going to turn out to be the number 351. So, this binary number, 101011111, base 2, is equal to 351. Now, if we want to emphasize that this last one is a decimal number, sometimes we'll write this as 351 base 10. But these mean the same thing. These mean the same thing. If I don't write parentheses and then a base, assume that I'm talking about base 10. That is, assume that I'm talking about a decimal number. Okay, moving on. Octal and hexadecimal expansions. The most important cases in computer science are base 2, other than decimal, are base 2, base 8, and base 16. Base 8 expansions are called octal expansions, and base 16 expansions are called hexadecimal expansions. So let's do some examples of those. That right there should be an 8. I want to convert 7016 base 8 to decimal. Now, this is going to be 7016 base 8 is going to be equal to 7 times 8, because 8 is the base we're working in. And so what exponent does that have? Here's the 0 place, the 1's place, the 2's place, the 3's place. So this is going to be to the 3rd power plus 0, because that's my next number, times 8 squared plus 1 times 8 to the 1st plus 6 times 8 to the 0th. And again, you'll get out your calculator and evaluate this, and you'll see that it's 3598. 3598. Again, that's 3,598 base 10.